Hello.
Hello.
Is that Jordan?
Yep, this is Jordan. Who all's there?
Jordan, we have, it looks like 19 people or 20 folks on the line, as well as Anton, Daniel, and myself from Ponton.
Nice.
Good morning, Jordan.
Hey, how's it going?
Perfect. I guess we'll go ahead and get started now. So thank you everybody for joining us. My name is Ashley DeGuzman with Ponton Industries. We're really excited to share with you the Deragger product line, which is more relevant than ever in this COVID-19 world that we're currently living in. So it's great timing, and we're really happy that you're all here to learn about this. Before we get started, I just want to go over a couple housekeeping items. First of all, you were all muted upon entry. However, we do want this to be an interactive webinar. So if you have any questions along the way, on the left-hand side of your screen, you should see a little question mark with Q&A underneath it. That is an area where if you click into it, you'll be able to ask us questions. And Anton Loof, who will be leading the presentation, actually has several points built into his presentation where he will stop and address any questions that have come up thus far. That way we can make sure that we're keeping engaged, answering your questions as they come up, and the like. So other than that, just of course, we're all working from home right now in these crazy times. So we apologize if there's any background noise, dogs, kids, things like that. Just bear with us. But other than that, I will go ahead and turn it over to Anton and get us started. Thanks.
Thank you, Ashley. Can you hear me okay?
Yes, yes, we can.
Okay, good. So I had to check because our last one, I was a little bit too loud. And as Ashley stated, yes, I'm also at home. I've got 2 boys in the other room supposedly doing their homework, and my dog is being quiet so far as well. So I appreciate everybody's time here today. I see a few familiar faces here, so thank you for joining me. And clearly your interest is in pump deragging and the issues surrounding that. So we have an interesting presentation here about some of the possible solutions to ragging of pumps and what might work in your system as well. So if you would just enjoy and ask any questions, I will stop, as Ashley mentioned, throughout the presentation and at the very end as well. All right, so a little bit about Ponton Industries. Quickly, we're a 50-year-old company. We are a manufacturer's representative, and we cover Nevada, Hawaii, and California. So these are just some of the major manufacturers that we represent in California for all types of products related to municipal water, wastewater, and conveyance, as well as industrial. So a little bit of everything. So pump blockages. We're going to talk about what the problem is, some of the potential solutions, as well as a suggestion that we have is our solution regarding real-time pump protection. All right, so let's get started. So what causes ragging? I think you all know what causes ragging. People throwing things in the sewer that doesn't belong there. Anything from so-called flushable wipes to the little cherub in the middle who thinks that the toilet is a trash can, and the results are essentially at the end something you don't even want to touch with gloves. So there's all kinds of things that can go in the toilet, but things that only belong in the toilet. You know, I've heard people say the 3 Ps. I once asked my scout group that question. Of course, I had to bring in wastewater into the scouts, and somebody chimed in and said, "There's a 4th P, and that's puke." So now I understand there's 4 Ps that belong in the toilet. So this graph came from the industry who actually manufactures wipes. And they, a few years ago, actually projected the wipe sales to blossom, and they were gleeful to say that it would nearly double in 7 years. And this is an old graph, so I shudder to think what this graph really looked like considering the last 3 months, as well as the percentage of usage throughout the world. I think it's far greater than 50% at this point. And it's only projected to go up. So unless something is done to stop this, it's going to get worse and worse. So this page illustrates the views of the disposable wipe industry, what they call the non-woven materials. And this is from an industry trade show called the World of Wipes. And they contend that it's not wipes that are causing the problem, it's people throwing inappropriate, quote, non-flushable items in the toilet. So they don't take any responsibility for any of this. So until legislation occurs, we have to deal with the problem in the collection system. So imagine those of you who have been able to get out and do a little shopping here. This is an image of what the shelves look like at Target. So just imagine where all of these products have gone. And I would say the majority of it, these type of wipes, have gone into the toilet. Especially if they're cleaning something, people will throw it in the toilet. There are some who throw it in the trash can, as they should. But these are shelves and shelves of just one store of materials that have gone down the collection system. And this is the end result, is your operator, your collection system crew, going into the system to solve alarms and problems of a clearly clogged pipe. So that's just a quick primer of any clogs. And I'll stop now for any quick questions if anybody has any. And I do not see any typed. So Ashley will chime in if she sees something pop up. All right. So the impact of clogs. Many of you suffer the impact of clogs, be it clogging of the impellers, causing floods and surcharges, causing damaged motors and pumps. But the impact is clear. It isn't something that's nebulous and buried in the statistics. It's hard, it's real, people touch the impact. One of the impacts that are hard to quantify for a lot of people is energy usage. Many agencies and districts don't track their energy usage as they probably should in a pump station. Pumps have been reported to be the #1 energy user in the USA. You're pumping water from rivers and creeks and power plants and water plants and wastewater plants. And any fraction of a percentage saved in the conveyance or pumping of water is a massive savings of energy. An engineer might design a pump station to operate at 90 seconds, when in reality, because of the problems within the collection system, it may actually run for 3 times that amount of time, as well as drawing far more energy and pumping less because of clogs or head or another reason. So there's the ideal flow curve, and then there's the reality flow curve. And whatever you can do to change reality to give it an improved flow, the better. So you might have, oh, there's my dog barking now. You might have, during one day, $4,800 a year in pumping costs, and in reality, it'd be about $10,000. So let me put you on mute and yell at my dog real quick here. My dog says he's sorry. All right. Another dramatic effect of a rag pump is the pump will not run smoothly when it is ragged up. It'll tend to be imbalanced, vibrate, draw more current and energy, and those have lasting effects such as making your windings heat up higher in temperature, and that'll reduce the life expectancy. Your bearings will require replacement more often, and your seals can actually leak prematurely and causing pump failure or worse, even motor failure. Safety to your employees who are required to go out and clean a pump because it's not pumping efficiently. So needle sticks or other sharp objects are a danger. Physical injury, whether it's to a back, even stubbing your toe, dropping something on your foot or wrench, let alone getting injured by the pump. So injuries are probably the highest risk factor as far as a cost is concerned to having a clogged pump. Biohazards. Well, we all know about biohazards. hepatitis, and there's even studies that show that COVID-19 exists in the sewage, albeit at lower strengths. But biohazards of all types are in the sewer system, and collection systems guys know this. They don't need to be told this. EPA and fines, and also damage to surrounding homes. You know, you have a leak, that's a problem. So the cost of repairing somebody's basement or first floor because of a pump leak can be very expensive, into the thousands, if not tens of thousands. So where are you typically wasting money? Well, the biggest potential costs on having blockages could be injuries and lost time because somebody got hurt, fines, or costs to repair homes. And then we get into the man hours. You know, there's money associated with that, wasted energy, and then pumps and repair parts for those pumps. And at times, even wasted energy can be greater than the man hours, depending on the size of the pump and how much water is being pumped. So how do pumps rag? A number of different ways, and it's really where do pumps rag? In the wear ring, in the eye, in the volute, upstream, downstream. There's a number of places where a pump could rag up, or a clog could happen. You see the graphic there on the top left. It's essentially the leading edge will capture a rag and start capturing 1, and then 2, and then 3, and then it goes on from there. So the idea here is that we want to prevent these things from happening like this. So what types of pumps can rag? Every type of pump can rag. It depends on how much they rag, and as soon as they start ragging, they become inefficient. So a ragged pump is not an efficient pump. Any questions? All right. Let's keep going. All right, so what are your options? I painted a very sad picture of what could happen in your lift station and what probably does happen in some of your stations. You have a few options on what to do with that debris as it comes into a station. You can grind it. You can get all types of grinders to grind the debris before it gets to the pumps. You can change your pumps into a different style or a different blade or different impellers. Chopper pumps, for example. Or you can, what we say, pass the debris. So don't need to really necessarily get rid of the debris. You just force it through the pump in such a way where you're not causing a blockage, but you are allowing the debris to pass through a pump. So a chopper pump or a grinder is a piece of hardware, which when the flow comes into a grinder, it emascerates the material. So if a rock comes in there, it just grinds it, or a piece of wood, or sticks, or baby wipes, or whatever, and it's constantly running and grinding it up into small pieces. Similar to a chopper pump, it chops it into little bits and pieces, similar to the graphic at right. Essentially, it just grinds it up into little pieces, and it's easier to pass that way in those two options. So, but the result of grinding is it will grind it into small bits and pieces of pulp. And so what happens after cutting or grinding is it will end up going to the bar screens at the treatment plant, and it may not even get caught. It may even go through that, and then now you're affecting the process within the wastewater treatment plant. Sure, the collection systems guys, they say, well, it's not in their problem list anymore of having debris in the pump station. They're running, but now the treatment plant is having to deal with these small particulates within the plant. So they often will pass through screens after being ground up into small little pieces. And here's some graphical examples of what that looks like in the headworks of a treatment plant. It's sometimes mop-like, sometimes stringy, sometimes just like oatmeal. It will just pass through. So after cutting out in the collection systems, you may or may not be able to grab some of this or collect it in the headworks. So what are your options other than those two options? it would be pass. So we offer the product called the Deragger. Deragger is a small product that fits on a DIN rail, and these two guys are kind of a little bit of scale to show you with their hands how small this device really is. And so this is nothing mechanical, but purely intelligence and electronic, looking at your pump using what we call real-time pump protection. The Deragger itself sits in the back of a panel and constantly monitors your pump for the potential of a blockage and initiates a cleaning sequence on startup when it detects that the pump might be clogged. So how does that work? So in real time, we measure the current and the voltage in a pump, and we calculate power on each of the three phases. So as we monitor the phases, we can make a determination as to whether the pump is clean or getting dirty. Now, just a quick note here, this only works really on three-phase pumps. There are some means of changing some pumps for this to work, but really a three-phase pump is where this device actually works best. So if your pump was linear and uniform, it would be pretty simple to say, hey, anytime my power goes over a certain level, let me know that there's a problem, or if my power gets reduced, let me know if there's a certain point. And it could alarm and trip and have some sort of action based on these two things. But in reality, that's not how a pump operates. A pump operates at different frequencies oftentimes with a variable frequency drive, or on startup and winding down also. So it's a little bit different in reality, and that's what's different about the Deragger product, is it actually can calculate the power usage at different frequencies. So it's like having multiple set points at different parts throughout the range, and calculating whether the pump is in nominal, normal circumstances, or is above or below. So if the pump is just spinning in place, you might have low power requirements. And if it's pumping, it's because it's clogged, your power output or your power usage is more. So the ability to measure torque and how much energy is actually used is key with this device over an entire range of frequencies. So how does a pump happen, or a clog happen, I should say, with respect to the Deragger? What's the decision process, if you will? So a pump is told to turn on. The Deragger then monitors the power requirement and torque and determines whether it's within range or not within range. So if it senses that, oh, I have 1 or 2 or 3 baby wipes, just enough to get it to trip, it will then stop the pump, tell it to reverse for a couple seconds, stop the pump again, and go back and try pumping again. If it finds that the torque and power usage is nominal and within the normal range, it goes back to what it was doing, and it's waiting for the next call of the pump to start. So it resumes in what's considered a clean operation. If it finds that it's still dirty or without the range, or beyond the range, I should say, it will initiate another cleaning cycle up to a maximum that you choose for your station. If it's not able to clean it, then it will trip an alarm, and your SCADA system will tell you, unable to clean this pump, somebody please come out here. And there could be something giant in there. It could be a 2x4 in there that it just can't pass, or a chain or something mechanical. What you don't want to do is keep trying to pump, with a 2x4 stuck into your pump station. So what is this device compatible with? The Deragger works with VFDs, soft starts, across the line, all types. In fact, I think it probably works best with a VFD myself. What kind of pumps? Any kind of pump, just about. Enclosed, hybrid pumps, screw pumps, chopper pumps as well, vortex pumps. Now, some people ask, well, can I reverse my pump? Well, we have letters from a number of manufacturers who've shown that, yeah, you can reverse it, and this is what you need to do to ensure that the safety of the pump and the integrity of the pump. It's been a long practice for a lot of old guys in the field that they mechanically actually switch the wires around and temporarily reverse it just to clear out some blockages. and this does it automatically. Now, I wouldn't, if something is completely clogged, we're going to see here that you don't want to reverse it if it's completely clogged. It's far too late to do that. So the impeller on the left, you can reverse that. You can reverse that because it's not really clogged that much, but I would not reverse something on the right. There's a little bit too much risk associated with that to damage the pump. So this graphic shows that, hey, can I do this on just using current? No, you don't want to use just a high current alarm to say do it in a PLC if you wanted to, write your own code within a PLC and reverse a pump. It could be too late. You could actually snap the shaft, and that's a problem. So again, it's same as the previous slide. You don't want to reverse a clogged pump. That's a problem. But before it gets clogged, if you will, 1 or 2 wipes, then yeah, you can get away with that, but not at all when it's completely clogged. So where does this thing get installed? These are a couple small panels as examples. The panel on the left is a VFD panel. I find that that's probably the cleanest, easiest installation because there's no need for any other hardware. You have the VFD there already, and all you need is a little space on a DIN rail for the Deragger device. The example on the right shows an across-the-line example. Again, the Deragger on a piece of DIN rail, but you need to add a reversing contactor in this case. So a reversing contactor is required, or a method of reversing your pump is required. So here's some of the wiring, if you will, for a VFD. Your run signal coming in from a device such as an ultrasonic, a surge pressure, a hydrangeur, will tell the Deragger instead of the VFD to start the pump. The Deragger then tells the VFD to start it, and if it finds that the current and voltage and calculated power is not within the normal range, it will tell the VFD to go into reverse for a second and then go back to normal operation. So this is really simple wiring on how to do the VFD. Across the line is a little bit different because you do have to add a secondary starter for the motor. And you need to have a little bit of space, or a lot of it of space, depending on the size of your motors, in your bucket to do this. You may have to have a panel on the side of it, but the gist is the same depending on horsepower. They all get wired the same. Signal comes in to the Deragger tells which starter to start, whether it feels it's clogged or it needs to go in reverse, or just normal operation. So the overall schematic here is a level sensing device telling the Deragger, telling the VFD to measure the current and power, and then start the pump in forward or start the pump in reverse. One other thing you can add also is a flow meter. So we've done some systems where we've installed the Deragger, and you get a flow meter, and then you achieve the ability to measure gallons per kilowatt hour. All right. I'll stop here for any questions. If anybody has any questions on that. It's all quiet. Is everyone in a lunch coma? Okay, we'll keep going. So what do you get with a package? You get the software, you get the Deragger, and you get a keypad. And the benefit of all this is not only do you have the deragging capabilities, is you have the ability to log and save all of the data, such as run times, how many times it had to initiate a cleaning sequence. You have your ability to track energy usage in kilowatt hours. So now you have on a memory card, or the ability to download memory into a laptop, your full functionality on a memory stick or a memory card. It also has a USB port so that you can download data to a USB via the USB cable into the software. Oh, did somebody have a question? All right, never mind. keypad has a number of functions. You can see the operational data of your pumps, starts, stops, how many times it had to do a pump cleaning cycle, energy usage, and any diagnostics information. So this sits on the dead panel in the front, so you don't have to access the electronics in the back. Included within the Deragger are what we call apps. And there's a number of functions with these apps. Anti-ragging is the standard default for the basic Deragger. Motor protector, data logging, wet well clean cycle, dry run protection, float switch, odor control, and what we call derived flow. So it can actually calculate flow on non-VFD applications, as it's pumping up and down. So what are some of these things? I won't read this verbatim, but anti-ragging is the functionality of keeping the pump clean. Energy monitoring and data logging, it allows you to track your voltage and current and power on each of the phases and energy consumption. Motor protection, overload, imbalance, overcurrent, undercurrent. Built-in data logger. Wet well clean is to pump down the wet well below a certain time. Let's just say every 24 hours at midnight you want to tell it to pump down to 10 seconds beyond the set point. It'll do that. Dry run protection to prevent an operator from leaving it in a run and then just driving off. And then odor control for those stations that maybe don't pump very often, and over the weekend as an example, and you don't want it to stink, so you will pump out whether there's a high set point or not. It'll pump it down to try to eliminate some of the potential for septic water. So there's three models of the Deragger. There's the Deragger Plus, the Light, and the Power Monitor. The Deragger is the full-blown unit for all horsepowers and all of the apps, if you will, built into the unit. The Light is for the smaller pumps and doesn't include VFDs or data logging or any of those features. And if you don't have any ragging problems and you purely want to just use it for doing power monitoring, we have the PM version, the Power Monitor. Okay, so we have a question here. If the VFD is using communication network type commands for run stop, then does this support industrial network protocols like Ethernet IP, field bus, etc.? Jordan, you want to chime in?
Yeah, so it needs a hardwired run signal to be able to tell the Deragger to start and stop. There are some ways around it. Sorry, my dog's acting like a lunatic. But yeah, so we do have the capability of talking Modbus TCP, but still to be able to run, for the Deragger to receive a run signal, it needs to be a hardwired run signal instead of, say, Ethernet IP or something like that. That makes sense.
Do we read the current and voltage from the VFD via communication protocol, or strictly the CTs in a connection?
For the Deragger, it's reading directly from the CTs,
okay.
not the VFD.
Okay, so I guess the question is to communicate or tell the commands for run stop. It's really just a 4 to 20 signal to the drive. Is that correct?
So the way it works is like if you're connected to a Hydro Ranger, then that's going to give you, it's going to send the output from the Hydro Ranger to the input of the Deragger. Same thing with a PLC. It's a digital signal, not an analog signal. But it needs to be a hardwired signal.
What tells the VFD to go at a particular speed? The Deragger does, but how does the Deragger? What options are available for the Deragger to tell the VFD at what speed to go and whether it's forward or reverse?
The Deragger only sends digital signals, so forward and reverse. The the hertz for the run for the speed that it needs to run, that's going to come from your PLC, not the Deragger.
Okay. All right. Hopefully that answers your question then. So the hertz, yeah, whatever is telling the VFD now at what speed is going to still come from the same control system, but the VFD is going to look to the Deragger for whether it should be in reverse or forward condition.
Correct.
Okay. Hopefully that answers your question. Oh. All right. So people say, hey, my pumps don't rag too often. So what? Why should I have this product? Well, we all recognize these. These are the things that come in your mail every month. These are the energy bills. And energy is, I think, a large component of what benefit this Deragger product has on a pump station and how much energy it can save. It's pretty shocking sometimes, and it's almost unbelievable. I would say it's even embarrassing, some of the results we've had, that people don't believe it until they grab their bill and realize, wow, it has gone down. And there's a number of reasons why it goes down so much as it does. So we have a number of case studies that show two things: reduced energy and or reduced ragging and call-outs based on problems. So you can see more of these case studies in detail at the URL that you see on the top right there, so the deragger.com/case studies. So this is a graph showing a sample power usage before and after the Deragger has been installed. So before it gets installed, you have an up and down cycle for energy usage, or current really, which equates energy usage in a pump station. And so it goes up and down, depending on the clog situation of the pump. And it gets completely smoothed out with the Deragger installed because it's constantly monitoring and dealing with it at that particular time. So is this the holy grail that we found? For many stations, it actually can be, or the gauntlet, I should say. So we have a question. Will the Deragger work if you're using a single-phase 240 volts and a VFD to utilize a three-phase motor? Jordan?
Yes, sir, it will. That's normally what everyone does. That if they've got a single-phase system, is they'll put a VFD in, change the motor to a three-phase motor and pump, and the Deragger works great that way.
All right, thank you. All right, so the Holy Grail. What do I call the Holy Grail here? The Holy Grail is essentially now you're getting an efficiency on your pump station. This is really what everyone should strive for. It's like driving, I like to say, it's like driving your Prius down the street. You now have a dashboard that gives you miles per gallon in graphical trend format. And there's this psychological thing that happens that you say, oh, let me see if I can get 48 miles per gallon. Let me see if I can get 49 miles per gallon. So you start operating your station or your car in a more efficient manner. So if you see in a graph of historical data or on SCADA, your efficiency or kilowatt usage go up for the unit number of gallons being pumped, you know there's a problem in your station if the energy usage is suddenly going up. So being able to track the energy, I think, is key on some of this, to know from a maintenance perspective that you have a problem in your station or not. So here's a couple of case studies that we have that I pulled up. They're both in California. This one is in Los Angeles, and it's for two 50 horsepower pumps. They suffered from pumps being ragged up, and they had to send crews out maybe a couple times a month, 4 times a month, multiple crews. These are pretty good-sized pumps. The risk is for lifting the pumps. Of course, there's the bio risk and sharps, and just getting hurt. And also, energy consumption was more taxing on the motor than if it was clean. So the results of this station was that after installing it, they haven't had to clean the pump in over 4 years. Now, this graphic is old, so I would say this is probably more like 6 years or maybe even 7 years ago. The energy savings, I would say, is actually nominal. It's crazy that you would say 4.5% is nominal, but that's pretty low in the scheme of things. But it does happen. Another case study is something in my neighborhood, actually, in Northern California. This is a 3-phase 25 horsepower pump for 60 volts, and it's not a big station in the scheme of things, about a half MGD. But I personally saw the flow meter after the pump is cleaned. The flow meter that they have on the wall, the mag meter said 0.8 MGD, and when it was running, and 4 or 5 days later, it said 0.45 MGD. So it was a massive change in the efficiency of the pump itself. Their problem was that it would clog twice a week, and they had to send a collections guy, just one. It took one guy. It took him about an hour at a time to clean it out. You know, he was exposed to having to lift the pumps, the potential for sharps, and then the energy consumption as well. So I see a question, and my little puppy is barking. Okay, let me read off the question here. I think my rags are collecting in my wet well and then get sucked up by my pump in the pump station next to the wet well. So we get an instantly clogged impeller. Will that be a problem reversing the pump at that time? So the debris builds up and then gets sucked up. Jason? Jason?
You know, when it starts to collect rags, if it can catch it pretty quick, it's not going to be a massive rag ball like what some of the pictures you've seen. So normally it's okay to reverse it so it'll clean itself, and you could probably do it a couple thousand times with a massive rag ball in there, and it probably wouldn't hurt anything. But that 1,001 time, it could tear something up. So it's you are walking a fine line with something like that. But the whole concept of the deragger is to catch those first couple rags that get sucked in before it creates a massive rag ball. So you should still be okay. And because if you suck in something too big too fast, your chances of motor overload protection, shutting everything down, is probably what would end up happening.
So I'm reading the question a couple times here, and I'm just kind of wondering if you reduced your off point or lowered your off point on this station. I'm guessing from what I'm reading here is that it is building up in the corner somewhere, and then suddenly it comes out of that corner and gets sucked into the pump. So I'm kind of wondering whether the scheme would change a little bit if you were to lower the set point and maybe pump in the debris more often. It would be one of those where we could take a look at it, and or you can send us maybe a video of it or something, and or better describe it on some drawings, and we can make some recommendations. There's another question here. Are there such drastic improvements in clogging frequency in situations with higher flow rates, 5 to 8 MGD instead of 0.4? I think the improvements are a function of, those are some high energy usage situations, and you're probably having some pretty good sized pumps at that flow rate. So pulling those are probably difficult. And then the effect of improving energy at a bigger pump like that is going to be more drastic. But I don't know. You haven't seen the results of the next page, if you will. So I'll change the slide. So Half Moon Bay had 19% improvement. Would you see 19% improvement on a station with 5 to 8 MGD Jordan, do you have any examples of a big station like that and big improvements in energy?
I don't remember. I know there's some on the website where we have had some really big improvements. I know some of them, the larger pumps, I mean, you're going to see a lot bigger improvement than you will on the smaller pumps. And some of them, we've seen up to 80% savings. And we've got that documented in some of the case studies online. I don't remember which one, but if you look through them, there is one in there. It's been amazing.
Yeah, so I think dollar-wise, you're going to see a big improvement. But as far as a percentage, I'm not sure if you're going to see 80%, but you're going to see a percentage, but your dollar-wise is still there. So, you know, the cost of the Deragger for a 200 horsepower pump is the same as on a 20 horsepower pump. So if you're saving, you know, if you're saving on this example $500 a month in PG&E bills, that's a lot of money for this small station, but it may not be a lot of money for a bigger station. But if you're saving 19% or just say even 10% on a big station, that's going to be a bigger dollar amount for those larger stations. So I don't know if you're going to see the dramatic percentage improvements, but you should see dollar improvements that are quite large. But in this case of Half Moon Bay, their bills between July and August were a difference of about 19%. And that's a good month to do a test in because there was completely dry weather flows and comparable as far as non-school. And so looking instead of November to December would be a little tougher because of the potential for wet weather. Their labor savings alone for the 6 or 8 trips out there worked out to be about $735 a month. And these are not numbers that we calculated. These were calculated by the agency. So they wanted to see what their ROI was, and they came up with about a $15,000 savings per year for just this one pump. So how does it do that? How does it save all this energy? So if your pump was always clean, as you see here, you'd be running at a constant efficiency. You wouldn't have dips in your efficiency because there are no clogs. But in reality, you do have the potential for clogs, whether you know it or not. Many clogs will actually clear without any interference by you. And so you have this constant sawtooth graph of efficiency. Very high when it's clean, and as soon as you drive off, it goes down and low and low and low, and then you get back there and you clean it again, and in the same cycle every week, every month, every 2 months. So your net average goes pretty low. So instead of operating in the 90s, you could be in the 70s as far as your efficiency is concerned. The Deragger instead uses real-time protection. So instead of you reacting to an alarm a couple weeks down the road, it senses something right away and initiates the cleaning cycle. So you do have a sawtooth pattern. It's just very small, and it keeps the efficiency higher. And so this is where we gain in the energy savings. Your pump is running more efficiently than when you don't have it cleaned up. This is an older map showing some examples of where we have the Deragger installed. This is probably a couple years old at least. So we do have more reference installations throughout the United States. You know, I want to say, if you actually do a Google search for Deragger and look up videos, you're going to find quite a bit of news reports, you know, be it CBS, ABC, Fox. They're going to have news reports in towns throughout the U.S. where they've had clogs, and they've actually told the news people that they installed the Deragger and have not had problems since. So it's kind of interesting watching the product on the network news as well. So in summary, what do you get with this product? You save on energy costs, save on your labor costs, your reduced pump times because it's more efficient, and reduced times make your pumps last longer. You reduce vibration because of a dirty pump, again, making your pumps last longer. And now you get to track the efficiency of your station to calculate gallons per kilowatt hour. So there's no need to install a grinder. That takes engineering costs to figure out where to put it. It takes more energy, ironically, so you're going to add to your electric bill. And of course, buying a new pump is an option, but those, you could get into the tens of thousands to buy a new pump, and it's still not going to have the efficiency of keeping itself clean all the time. So there's some drawbacks to all that. So again, the options that you have, expensive to install a grinder or a macerator, expensive to install a chopper pump. There are some self-reversing pumps out there, but they're not really monitoring throughout the range of the frequency and speed. That is a patented item. And then there's the cost of the deragger. It's quite small, relatively speaking. So what is the cost of the deragger? So instead of hiding that from you, I'll show it to you. So deragger is about $5,500 for the device, and you get the current transformers with it, you get the keypad, and all associated cables and fuses that belong to it. All you have to do is install it. We provide the software as well. It gets configured, and we can even provide installation assistance or startup. And it's been installed by districts directly or by service providers such as Tesco or Telstar or similar integrators as well. The light version for smaller stations and smaller pumps is a couple $1,000s less. And if all you need to do is measure energy, it's even lower than that. So it's only $2,400. So that requires very little installation if you're just doing energy, because you're not having to do any controls with that. So that's the deragger in a nutshell. Is it the end of ragging? There's always going to be something that can clog a pump. But for the most part, I think most stations will benefit greatly from something such as this product. Any questions? Any more questions? The average installation costs. That varies on where it is, of course. Some quotes here. Marty, let's see here. Can we unmute Marty, perhaps?
Let me try to let's give it a second.
Of course, I assume Marty's on the line.
He is. I just sent on allowed to talk, so it's this one.
In any case, yeah, there might be an issue with his mic. I see something about error in using the microphone. Yeah. All right. So I don't have an idea, but it only takes on a typical application. It takes a day. In a typical application, if you had to install a reversing contactor, that adds some money to it because you have to pay for the reversing contactor. So it really depends on the installation. But I would say anywhere from $2,000, it's probably $1,500 to $2,500, depending on the site. That would be a typical installation cost if you're not going to do it yourself.
Okay. We also have Michael Riley, I believe, is about to get on the line.
Yeah, Michael. Can you hear me?
Yeah, Michael, I can hear you. How you doing?
Fine. Interesting production here.
Thank you.
Do you really need reversing contactors to make this work?
Yes, in a station that does not have a VFD, you do need a reversing contactor.
Okay. That was my question.
Okay. A lot of your stations have the Siemens Robocon VFD, so it'll work with those as well.
Yeah. I was trying to find a wiring diagram, but I can't find it online. I see lots of manuals and brochures, but nothing.
Michael, I'll send you an email, Michael. I'll send you an email with the wiring.
Okay. Thank you.
All right, you're welcome. Let's see here. Is there any research or literature available regarding reversing pumps and if there are long-term negative impacts on the pump from reversing that? I will find out. Lexi Valenti, I assume we have your contact information. And let me write this down. As far as documentation, we're obviously not the pump manufacturer, but we should have some information regarding that. There shouldn't be any long-term consequences of doing that. Mechanically, we have letters from, Flight and, some of the other larger manufacturers that say it's okay. There might be limitations on some of the larger pumps on how many starts and stops you can have in a given time period per hour, for example. So a cleaning cycle does count towards that. So if you have large pumps and the manufacturer says do not start this pump more than 3 times, 5 times per hour, that counts. The cleaning cycle counts towards that limitation as well. But I will find out and see if I can get a hold of you and get you that answer. Let's see here. I think I answered the question. Average install costs. I think that's about it. Any other questions? Well, I'll sit here for a couple minutes. So if you're thinking of something, please press the button there on the top left, the question mark Q&A, and type in your question, and I'll be happy to try to answer your question.
Hi, Anton. It looks like you did get one question. Oh no, this is Marty. We can assist with stations with no flow meters.
We can assist. Yeah. So what the question here is, we can also add flow meters to these things. So as a representative of Siemens and a couple other manufacturers, we have the ability to add flow to an existing station to give you that kilowatt hour per gallon metric, so that you're able to trend that. The Deragger also has a Modbus or 485 output, so SCADA is able to read many of the registers within the Deragger to give you that energy, and then you have the kilowatt hours, and then also in addition to that, you could then read the flow value to give you that trend of kilowatts per gallons. The warranty and tech support, Jordan, 1 year's parts and labor, I believe. And the labor is a repair, so we'd probably end up sending you a new one to replace it if there was a problem with the Deragger. Tech support, it's probably best if when we use a integrator, that integrator, since they installed it, would be providing some of that tech support. But we also have tech support for any functions of the Deragger itself, and that would be via phone and email to support you with the settings on that unit itself. Yeah, no other questions? Well, I appreciate everybody joining us, especially many of us are at home here dealing with our home family and our issues here. So I'm finding more and more people are asking for some of these. And so I thought since we put out a flyer out a couple of weeks ago, many people had called and asked about this product and were interested in learning more about it. So we decided a few weeks ago to do a presentation on it. Hopefully this was useful. If anything, just to get your mind thinking about it. If you have any questions, please give us a call. On the screen, you'll see our phone number, our general info email address, easy to remember, and it will get redirected to the proper person depending on what your question is. And we'd be happy to help you out. And we're even traveling using, of course, the safety requirements here. We're traveling to sites. I'll be headed off to a well in the next half hour here to do some well level measurements. But as long as you let us know if that's okay, we'll be more than happy to bring our PPE and visit your site. Again, thank you very much for your time. Ashley, you have anything else?
I'm not sure if Ashley's there, but Anton, I'm right here. Thank you so much for the presentation. It was really informative. I'll be sure to follow up with all our attendees and make sure everybody gets a copy of the recording. Thank you so much. I'll probably be sent out tomorrow.
All right.
All right. Excellent. Thank you. Have a great
Guys.
day.
All right.
Bye.
You too. Bye-bye. Hey, thanks, Jordan, for joining us.
That was a really good training. I like the way y'all have done this.
Got to get that dog in order, though.
Yeah, I'm telling you.
That dog don't hunt, as they say.